guys ready?
No, it's gonna work.
Yes, we can. 1 second at a time. 1 second at a time. Oh, we've already lost 7. Okay, so Chapter 6, Section 1, Law of Signs. What geometrical shape does this have to do with?
Triangle.
Hey, you got one right. Those of you that didn't even get that, we're struggling. Triangles. What kinds of triangles? Non-right ones. Why non-right ones? Well, if they're right ones, what formulas relate right triangles? A squared plus B squared is C squared. Easy. Or Sokatoa Choshikao, right? Sokatoa Choshikao help us out with angles and sides. Sine equals opposite over hypotenuse. Cosine adjacent over hypotenuse. Tangent opposite over adjacent. What is Choshikao? Cosecant is hypotenuse over opposite. Sha.
Secant is hypotenuse over adjacent.
He's stumping you all. Okay, Sean. Cow. What's that?
That's adjacent over.
Yeah. Adjacent over opposite is cotangent. Yeah? Now, do we also have that secant is 1 over cosine, just flip it? Cosecant is 1 over sine, just flip it. Cotangent is 1 over tangent, just flip it. Yeah, either way works. But we have Choshikawa, Sokatoa, and we have Pythagorean theorem. But what's going on with non-right triangles? Oh, wah, wah, wah. Does Pythagorean work? No. So therefore we have to have something else. And what is one of those something else's? Law of sines. What's another something else? Law of cosines. That's section 6.2 that we're starting on Thursday. Okay, here we go. So, long story short, you guys remember from geometry, right? Sides of a triangle are lowercase letters, angles of a triangle are uppercase letters. True? What's going on with the height? Anything special about him? He hits the base at a right angle. So we could do Pythagorean theorem with h and a and c plus a little bit. Or with h and a and c minus a little bit. But that just gets complicated. But we'll have to look through a few of those things because we are going to learn some more formulas. Formulas as well. Now, what do you guys notice about AAS, ASA, or SSA? Read it that way, not the other way, just for decency's sake. Decency, that's not the right word. Proper? Pete's sake. There you go. Anyway, to keep it clean. What's AAS and ASA and SSA? Question. What do all the A's and S's stand for? A is for? Angle. S is for? Sides. When have you seen these before?
Geometry!
Yeah, but what about it? CPCTC.
Oh!
Congruent parts of congruent triangles are congruent.
Let's go math.
Some of these, I know, he's chilling. He's not, he's working. He's working hard. He's stealing Mr. Crawford, that's what he's doing. Anyway, just kidding. A little jealous. AAS, ASA, or SSA. Some of these worked for proving congruence of two different triangles. If an angle is congruent, and a side is congruent, corresponding angle, side, or corresponding angle, side, angle, or, this one wasn't a good one though. Remember him? He didn't prove much. Actually, he didn't prove anything. And we remember that because we're like, ah! He's bad, right? Unless you're in the old days and he's just donkey, no big deal. But anyway, so, AAS, ASA, now, in this case, I need you guys to realize these are not proving congruence. These are not proving congruence. In geometry, they were. Now it's just what information you've been given. If I were you guys, I would write that down real quick. What information you've been given. You've seen this in geometry, that's true. And it still means the same thing, angle, angle, side, but you're not given two triangles and you're trying to do a two-column proof as to whether or not they're congruent. Instead, you're given one triangle, and these stand for the given information. What's filled in? I know, I'm in a mouse. It's a little bit rough. It's supposed to be in my iPad, and it's just not happening. But this is what's given in one triangle. Does that make sense, the difference between geometry and math? But I'm using what you knew from geometry to help you out in the sense of, oh hey, if I have this, this, or this, law of sines is best. And if you have something else besides this, law of cosines might be better, okay? Now, what do you notice about what do you notice about the first two? More angles. Start with A and more angles than sides. Law of sines is perfect, is golden when you have two angles at least. However, this SSA, he's a tricky one no matter what, so basically he's tricky for sines and he's tricky for cosines. I'll put little parentheses around him because there's no perfect way of doing that case. He's called the ambiguous case. He's tricky. He's not impossible, but he's tricky. So you're going to have to figure out which way you like, either the law of sines way in 6.1 or the law of cosines way in 6.2 as far as like what you're going to do on the test if this guy shows up. All right. Otherwise, question. Does it matter which formula you technically use? No. But if you solve, how many do you technically have to choose at a time? Just two. Pick two. It could be these two. It could be these two. It could be the first and the last. But you're going to just have two of these at a time, but this proportion is true and this proportion is also true. And depending on which one, like for instance, if you were missing a little a, maybe you should have the little a on top. If you're missing a big A, maybe have the sign of big A on top. Either one is just as valid. All right. So, this one. Why am I saying AAS? Look at the picture. Angle, angle, side. That's what they gave you. 45, 105, 20. Angle, angle, side. Or you could say side, angle, angle. Either way, there are two angles. This is prime for law of sines. Whenever you have more than one angle given, law of sines is the one to use. The goal, solve this triangle. For who? Anybody missing? You guys already solving? How are you setting it up? What do you think? Little a on top or sign a big A on top? Yeah. Well, actually, hold on. Big A is missing. Big A is missing. But
Just say, hey, who is
geometry. Say it. The geometry property, all angles in a triangle add up to? So 180 minus 105 minus 45, maybe easier, 180 minus 150. 30. Okay, sweet. So hold on, we're not missing big A. If we're not missing big A, then question. What should we probably put on top because he's our true unknown? Yeah, I like putting the unknown on top. It's a little bit easier. Because we know what's in the bottom in the sense of, okay, hold on, who's going under little a? Sine of 30 degrees. Which is nice. I'm tracking with that, but give us 1 sec. Who do I have to have in the other one? Am I going for the C or the B? Oh yeah, because what's the one side I know? Okay, so I need to have a known over here to help out. And then I have my sine of 45. Kiddos, at this point, the name of the game is solve it, and some of you are going to like to do this different ways. How many of you, looking at that expression, right away say cross multiply? Okay. How many of you just say, whatever, multiply the sine 30? Okay. Either way works. And to be honest, in this case, multiply the sine 30 is faster. If you cross multiply, you'll have sine 45 times a, you still have to divide. If you just multiply by sine 30, don't you have a already alone? What you do on one side, do on the other side. A is equal to. Now, if these were non-unit circle angles, what would I have you go to right away? That's why I told you to get it out. Yeah, your graphing calculator, right? However, since these are unit circle-y ones, what can we plug in instead and not have to go to our graphing calculator? Who's sine of 30? Good, square root of 3 over 2. Wait, 30! That's cosine. Struggle, undo, undo. What's sine of 30? 1/2. It's a struggle, you're doing 60. How about 45? Now, it's not going to be a pretty answer, sadly. We could do our nifty, like, multiply top and bottom by 2, right? We end up with 20 over root 2, which will be 20 root 2 over 2, which will be 10 root 2. Don't worry, I'm just going for it. I rationalized. But could you've got a decimal and rounded to, wait a minute, how many decimals do I like?
You want 3.
I like 3. What does the book usually say?
2.
Why do I say 3?
That's what you
That's what AP Calculus wants. The AP test wants. So why not get ready for a version, huh? But either way, if you're checking the back of the book, they would round to 2. Oh, they just use their graphing calculators. Cheaters. Question, how do I find my other missing side, aka C? Oh, Pythagorean theorem, we have to.
No.
No.
Oh, it's not right
It's
triangle.
not right triangle.
So
All
we
right.
have to solve.
E for effort. We have to solve. How are we going to solve? Struggle. We need to do law of signs again. So C is going to go over sine of 105. Is he in the unit circle? He's 90 plus 15 degrees. Nope, we're going to have to go graphing calculator. Or a half angle formula, but let's not do that again. Okay, so it's not that. What do you guys want to use? It's your choice. Do you want to use A or B? Either one, I now know a side to plug in. What do you want? B looks easier, I agree. 20 over sine of 45. You guys, you got this. Go plug and chug. Get me a decimal for C. Corrected 3 decimal places because that's what we're getting ready for in AP Calc. Forgive the dip in the box. Once again, you can cross multiply, solve for C, or just multiply both sides by sine of 105, yeah? Wait a minute, what mode are you in?
Yes.
Oh, we've been in radians all this time because we were doing unit circle-y stuff. Now it's degrees. 20 times sine of 105 divided by sine of 45. Come on, cool kids, what do we got? 0.321, everybody backing each other up? Sweet. Done, done, done. Let's keep going. So question, if we're given 2 angles, how hard is it? That's the plugging and chugging, right? But we can find the third angle real fast just using geometry, and the sum of 3 angles in a triangle is 180, no big deal. Then we can just set up, solve, solve. So what's going on with this guy?
Well, you gotta keep that going.
2 things. Number 1, it's ASA technically, and number 2, which doesn't really make a huge difference, I don't think. But number 2, there's no picture. Come on, geometers, or at least you were there at some point. What do you do when there's no picture?
You make one.
Does it have to be precise, or can you say not to scale?
It's not to scale.
Exactly, be like, whatever. And the more accurate you make it, the more you can double check in the sense of if the answers make sense, but technically, no stress. Whichever way you decide to go, clockwise, counterclockwise, doesn't really matter as long as you label them correctly. Technically, if you get familiar with the formula, maybe you don't even really need to stress about the picture. For instance, if we look at the givens, what do you think I'm putting on this side where we like to have all the numbers we possibly can have? Oh yeah, all the C stuff, right? And who am I going to solve for first? Little a, right? Because little a is the other angle that I know, so I can just plug that in real quick. C I can plug in because I already know the side. That's a degree mark. Oh. You guys can use your calculator, plug and chug. Oh, wait a minute, this is a degrees in minutes, right? Is there a way of, wait.
It's one.
Yeah. Where's the cheater thing? Second apps, right? There's an angle menu. As long as you're in degree mode, it knows what you're doing. You can type in 83 second apps, the angle button 20, the minutes button second apps. Remember? Sweet, use it. Solve for A, but after we have A, we still need, what else are we missing? Oh, we need little b, but before we get little b, what else do we need? Big B. Alright, you guys just keep solving, you got this. However, something to think about, to keep everything legal, even though you might round for the final answer, what do you think I want you to do as you're solving for another answer? Not round it, keep the unrounded version that you have stored in your calculator, right? When you're using one answer to get another, do not round. You can round when you're writing it down. Don't round when you're working with it. That just introduces error. We're not doing sig figs in here. I know, you're all disappointed. Are we close? What do we have for little a? I remember. I know the back of the book will only have 2. You can use theirs to check it, but you're doing 3 for me. For train and write, right? Angle B, what'd you get? Ooh, in decimals. Is it even? Is it just 0.1?
No.
Uh-oh. What else do you guys got?
42.067.
0.67. Anybody else? Sean's double checking. That's trouble. Is it working? 180 minus 83 degrees 20 minutes. Oh, 7, right? Or Amanda, you got that one, right? Uh-oh. Back her up. What are you guys getting for the angle? Remember, subtract 180 minus A minus C. I haven't heard a yes. Is the angle okay? Aha, okay. Let it be, what we get? Now you're talking. Yeah, they're killing me. We're good? Great. Okay. Does it get any harder?
Yeah.
Maybe. Anybody stuck? Anybody questions on process? Formula, we're just playing with it, solving for the unknown. Struggle. What is this? It's called the ambiguous case. It's called the ambiguous case. Get it down. It's called the ambiguous case. SSA, side-side angle, or angle side-side, it was the one that couldn't prove congruence for us. It would just mess us up. But it doesn't mean that we have to ignore it now. It's just a bit ambiguous. What does ambiguous mean? English people. Say it one more time, would you? Unknown, kind of. Not completely unknown though, right? I might be going kind of in a different direction. Iffy?
Not extra, or just say it out loud.
Might be more than one meaning.
Subjective.
Subjective maybe in the sense of how you infer what someone might or might not be implying. Someone is saying a statement that might be taken different ways. Here's the idea with ambiguous. So this is the ambiguous case. We can tell something, but we can't always tell for certain whether it is the only solution. Remember in math we're solving, right? We're solving triangles. Okay. So applied to that, ambiguous. If we're solving, maybe it'll work out, maybe it won't. And maybe there's more than one maybe. Huh? Maybe what's given to us is impossible. If it's impossible, how many solutions are there? Maybe what's given to us is impossible. SSA might be an impossible set of information. Now, for or ASA, as long as there are two angles and as long as both of them add up to less than 180, it's a possible case. We're fine. But when they give us two sides and an angle, sometimes it's not even possible to make a triangle. Sometimes there's only one triangle that can have that given information. Sometimes there's only one solution, one possibility, just like what we've been doing. With maybe a couple sides and an angle we have to solve for, but there's only one triangle at the end of the day that has that information. Only one set of data we're solving for, but the struggle is it's ambiguous because maybe there are two different triangles that can have the same given SSA, and we can't say for sure who's right and who's wrong, so we have to say either or. If we're solving for the possible number of solutions, at the end of the day we have to say, hey, it doesn't work. Hey, it does work and there's only one possible way. Hey, it does work and there are two possible ways. If there's only one possible way, there's only one set of little a, little b, little c, big A, big B, big C. If there's two possible solutions, there are two sets. Now, how does this work? What if I was to give you something like a given angle of 20 degrees. SSA, only one angle. I give you 20 degrees. And let's say I was to give you a side of, let's call him 10. And then let's do a side of, should have thought this beforehand. Who's a graphing calculator? Can I borrow one real quick? And you're in degree mode, right, Kate? Yes. Let's do a side of 4. So we know angle A is equal to 20 degrees. Little b is equal to 10. And little a is equal to 4. Now if you want to know what I just did, I just pretended like this was a right triangle and I figured out what this side would be using sine opposite over hypotenuse. It was 3.4-ish and I went just a little bit more than 3.4-ish. 3.4-ish is if it was a right triangle, but it's not. Okay. Now, if 3.4 is what you would need to connect straight down, and if I have a side of 4, this is my angle A, this is my side B, so that means this is angle B. Remember, sides and angles are opposite. This is C. Okay. What's one way that 4, if you had a stick and it was 4 long compared to these 10 units, what's one way that it could connect to this base right here? If it's not down, that's 3.4, it has to be longer than that. What's one way it could connect?
Shift it out.
Yeah. So 4 might be going out like this. So then B would be that entire side. That's one way. But why is actually this given information ambiguous and there are 2 cases possible?
Because 4 could also go in.
4 could also swing. Pretend that was perfectly straight. So here's the problem. Without knowing angle B, there are 2 different ways. 2 different triangles that could be formed. I could have A, B, C with 4 swinging in, or I could have A, B, C with 4 swinging out. That bottom side, I don't know how long it is, so it's up for grabs. It can be longer or it could be shorter. And that angle B is up for grabs. It could be an acute angle or an obtuse angle. This is one way where I would have 2 possible solutions. Now what if I was to change this data just a little bit, and what if I was to give you, now guys, we could use law of sine to set this up, we'll see that in a second. But what if I was to give you instead, A is equal to 20 again, let's keep that the same. Let's keep side B as 10. But this time, let's make side A equal to 3. I'm going to steal my picture. Now, how would this work out? If I had a side of 3 as my opposite side.
Well, it doesn't have to be 3.4 to reach all the way down. So no matter what we do, it would be like a swimming hinge and then touch like
Exactly. What's Sean talking about? He said a swinging hinge. How long does the right triangle have to be because of sine of 20 is opposite over 10? You guys can do it in your calculator. 10 sine of 20 is 3.4. How long does this side have to be a right angle? 3.4. What's the shortest distance between 2 lines? Or 2 points? Straight line. If that's the shortest distance, then what's going to happen if I just have 3? Aw, he's swinging. Is he ever going to hit? Aw, is this a possible triangle? Poor little guy. Nope. So here's my case 4. There are 2 possible solutions of this one. There are 0 possible solutions of this one. And how did I know? I compared it to a right triangle. I said, hey, what would it be if it was a right triangle? And that was kind of my x. And I said, sine of 20 equals x over 10. I tried to figure out who is that third side. Now guys, our book has this nasty, complicated table. It works. It's messy. I don't like having you guys memorize it because it's just memorizing for a test and you don't really need it. I'd rather you have an understanding. And so I'm showing you how everything is related. But when we got x is equal to 3.4 something, 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 we said 3 is too small. Doesn't cut it. So question, let's guys take a second. How could you make a case? You give me, use the same angle A, use the same side B, but what would be a little a that would only have one answer. Where does that go? You can play with it. You can play with the picture, you can talk to your groups, or you can play with your calculator. Can you figure out one that only has one solution? I'll make your best guess on what you have. I know. Anybody think of anything? What? What do you think, Sean? 10? Alright, let's check it out. So what Sean's thinking is, here's our little right triangle. 3.4 is the smallest distance possible. If this is 20, if this is 10, then his guess is that our other side would need to be 10. Question, if it's 10, could it hit there? Could it connect in a straight line to 3.4? The shortest distance, you can go through it, but that's not a triangle anymore, right? But imagine that you have that 10, it goes through. We have to swing it to make a triangle. Can we swing it this way? Is it going to work? It's going to be too long, but which way can it swing? So if we have something that's 10, it's longer than 3.4. It's technically like 3 times longer. We can swing it out, I just didn't have room. And it can connect this way. The question is, okay, so 10 can make one answer. Can it swing back and can it make one this way?
No.
Oh, it's going to be too long. It's going to not be able to fit within the 20 degrees. So this would be a case of only having one possible solution. Now, kiddos, do you think the math backs this up? Let's check it. How would we solve for, if we have angle A, right, he was down here, and if we now have angle B, and if we have angle C, how would we go about solving for our unknowns? And first of all, who are our unknowns?
Well, big B.
Yeah, we're missing big B. Who else are we missing?
Big B, little C, and big C.
Little C and big C. Oh, I think we're missing all sorts of guys. Well, hold on. Maybe we should ask ourselves, what do we know? Don't we know sine of 20? Wait, why am I putting a sign on top? Why am I putting a sign on top?
Because we're
Who am I missing?
solving for big B.
Oh, I'm missing angles. I only know 10. 10 is little b, right? I'm missing big B. I'm putting him on top just to make it simpler on me in order to solve. But how is this going to be different to solve? How is it a little bit harder?
Because we're going to have to use inverses.
We're going to have to use inverses because our big B is inside of a sign. And I'm still going to be able to multiply the 10 to the other side. When I multiply it, guys, doesn't it go away with that guy? And then multiply by 10, cancels out on this side, multiply by 10, cancels out on this side. So now I have sine of B equals sine of 20. Wait a minute. So who's B? 1. That's it?
Two sides are the same.
The sides are the same, so the angles have to be the same. I think that's geometry 2. Struggle. He made us an isosceles triangle. Now the question that we have to ask ourselves tomorrow, just for the beginning of class, and so everybody wants to take the test, I'll put you off to the side and do one example with them and let them work on homework. The example we're going to have to figure out is how on earth does the math show us 2 answers? Alright, cool kids, I'll see you later.
Have a good day, Miss B.
Thanks, you guys too. Enjoy